Part of my interest in soil science stemmed from when I was a very young boy, interested in nature, interested in farming, particularly because I was growing up around the countryside. So I was kind of face to face with soils on a daily basis. The most significant contribution I made to the area of soil formation is measuring the rates at which bedrock weathers into soil. It's very difficult by eye, almost impossible to watch that process happen. So I started working with techniques outside of soil science, using special isotope dating methods to be able to measure the rates at which bedrock slowly turns into what we know and love as a soil. So that was the first kind of contribution, measuring the rates at which that happens. And I guess the second part of this, the big contribution, is we now know how fast soil forms comparative to, say, the rate at which it erodes. So really, erosion, the loss of soil, is a key aspect to our understanding of how soils degrade. And climate change is increasing or accelerating the rates of soil erosion. Climate change has a really important impact on the ways in which soils are able to process their kind of functions. We know that organic carbon within a soil can degrade due to temperature, increasing temperatures, and that essentially sends carbon from the soil back into the atmosphere. So without that carbon, you have less stability, less protection. It's that carbon actually that kind of knits everything together. Soils are not only a store, but they can protect that carbon from going back into the atmosphere. And so I think one of the aspects within soil science at the moment is plants which are living can also secrete carbon in organic compounds whilst they're growing and developing, through their roots, for example, as exudates. There are many types of heavy metals, of course, and many of them are toxic when they get to levels which exceed the safety limits. Cadmium, lead, mercury, these metals are toxic not only to plants in certain concentrations, but also the microbial communities. Lots of land use types which can increase the likelihood of heavy metal concentration within soils. Typically these occur on more brownfield sites that we would call kind of urban sites, mining sites, industrial sites, any area in which there's exposure to industrial operations, because often these heavy metals are concentrated at those particular operations. So we can track the transport of heavy metals from soils to plants. We've got techniques that can do that both within a laboratory setting, but also in situ within the field itself. And we can start build up a picture of where the bottlenecks are in this delivery of heavy metals from soils to plants. By having a limit which is clear and explicit, it means that we can start to curb the concentrations of heavy metals within soils. And part of this is very simple. It's about explicit labeling. It's about communication and education to the community. There's always a need to investigate what's going on in the individual scale, but at large really, in terms of how we create that kind of scalable policy shift, it's around large regulatory standards within the industry, I think. So it's really important to kind of link up with other disciplines and work out where are the hotspots, what are the relationships with the operations in the area, how that impacts the soil's overall concentration of these heavy metals. Policymakers have a really important task collectively, globally, but also nationally and regionally. I think we need to start seeing soils as a national asset. History tells us that a nation that destroys its soil destroys itself, so that the right economic investment is made. In fact, I would go as far to say that economic development of a country really requires some economic investment in the understanding of soils. In particular now, soil science and the agri-tech industry has a real part to play in creating sustainable and resilient soils in the future. The agri-tech industry now is developing machinery, equipment, infrastructure that is able to collect data all the day, every day. I think in the next decade, as we've started to see in the last decade, the soil importance will not just be something of interest to farmers and those who manage the land directly, but also other types of industries that maybe up to now haven't really looked at soils with much regard.